Greetings, my name is Abigail Baker, and this is my Unit 11 project over solving a linear programming problem. The problem that we will be discussing over today and solving is one problem that is found in the videos of Chapter 5, Section 6 in the MML library. So, our problem is as follows. Find the maximum value of the objective function z equals 3x plus 5y. Subject to the constraints x is greater than or equal to 0, y is greater than or equal to 0, x plus y is greater than or equal to 1, and lastly, x plus y is less than or equal to 6. Before we continue, I want to first go over what it is that the problem is asking us to do. So, step 1, we are going to state the issue. We are going to state what is the goal of this problem. So, our objective or our goal is as follows. Find the maximum value of z that satisfies the conditions given. So in our problem, it gave us a list of constraints. So in our problem, it said that z is equal to 3x plus 5y, and it is subject to these constraints. Before we continue, I would like to kind of clarify what these constraints are and what they really mean. So I put a definition here, and it says constraints are conditions that place certain boundaries or limitations on potential values. And in this case, for our linear programming problems, we could see these as linear inequalities. So our constraints that are in the problem are these right over here. X is greater than or equal to 0, y is greater than or equal to 0, x plus y is greater than or equal to 1, and x plus y is less than 6. So, what do we do now? The next thing I want to go over is graphing our constraints on an XY plane. And so here on the left side corner, you can see I drew a graph, and I will kind of go over what I did here so we can understand how exactly we are to graph the constraints on an XY plane. So first things first, what do we know? So the first two constraints that were given, which are x is greater than or equal to 0 and y is greater than or equal to 0, well, this tells us that it's in the first quadrant. So that's why over here our little figure is drawn only in the first quadrant. And because of this, we know it's in the first quadrant. Secondly, we know that with this other constraint that was given to us, we can now graph the line x plus y is equal to 1 with the coordinates 0, 1, and 1, 0. So 0, 1, and 1, 0. So we go dot, dot, and then we connect. Okay? Great. And then we have the next constraint, x plus y is less than or equal to 6. And we graph the line x plus y equals 6 with the coordinates 0, 6, and 6, 0. So 0, 6, and 6, 0. We make a dot here, dot there. Now what do? We connect our points. So then what I'm going to do is I'm going to trace between these points on the y plane, the y, and then on the x. So this dot here and this dot here, we trace between those. And then over here, we trace between those. And this is how we get our region. So here I put our region that is outlined is because of the constraints. So the reason we have this is because of the constraints that were given to us in the problem. And what exactly is this shaded region telling us? Well, the shaded region shows us all of the possible and the potential solutions that satisfy the constraints given. And that is how we get through step 2 of graphing the constraints on an XY plane. The third thing that we're going to do in this problem is we are now going to find and identify the corner points. Corner points are also known as vertices. So I kind of here explain what they are and the importance, and then we'll go over what our corner points are. And we can go back to the graph and see visually what those points are, but before I continue, I will explain step 3 a bit more. So, what are corner points? Corner points are, here I said, corners of the shaded region on the graph where the lines meet. So in this case, it would be our coordinates, right? Those are our coordinate points. And why are they important? Well, here I put, if a solution does indeed exist, the maximum or the minimum value of the objective function happens at one or more of these points. And in this case, we are looking for the maximum value of the objective function. So not the minimum, but the maximum. So if we look back at our graph over here, we can see there are corners. And these corners give us our corner points. So our corner points are the coordinates that we found in step 2. So 0, 1, 1, 0, 0, 6, and lastly 6, 0. The next thing that we're going to do in our problem to further solve it is evaluate and plug these into the objective function. We're plugging in our corner points. So we have 0, 1, 1, 0, 0, 6, and 6, 0. If we go back to our original problem, we can see what the equation was for z. So it was z equals 3x plus 5y. And that is how I got these over here. So I just plugged in the corner points into the objective function. So we have here for number 1, z equals 3 times 0 plus 5 times 1, which gives us 5. Then 3 times 1 plus 5 times 0 gives us 3. And then you continue to go down, then you get 30, and we get 18. In our original problem, it was asking us to find the maximum value of the objective function subject to the constraints that were given. So with that in mind, when we look at these numbers, the biggest one is number 3, 30. So the maximum value of z is thus 30, occurring at the vertex point, or our corner point, 0, 6. And that is how we can solve a linear program problem using a graph. Thank you for your attention. God bless you.